Right now, somewhere beneath your feet, there is a city. Not a metaphorical city, not a loose comparison. An actual, functioning, climate-controlled, waste-managed, architecturally engineered city, built without blueprints, without cranes, without a single conversation between the builders. And the engineers? They weigh about 1 milligram each. Here is the part that should genuinely unsettle you. Some of these underground networks stretch 8 meters deep. Some span more than 6,000 kilometers across entire continents. One species builds a ventilation system so precise, it exploits the same aerodynamic principles human engineers use in skyscrapers. And one colony, just one, has been continuously occupied, expanded, and rebuilt by successive generations for over 60 years. By the end of this video, you are going to look at a patch of dirt differently, because what lives underneath it is not primitive. It is not random. It is one of the most sophisticated construction stories on this planet, and almost nobody is talking about it. Before we go underground, you need to understand what an ant colony actually is, because most people get this wrong. An ant colony is not just a group of insects that happens to live together. It is a superorganism, one entity. Think of it this way. A single ant removed from its colony is about as functional as a single neuron removed from a human brain. It will wander, fail to eat properly, and die within days. But plug that neuron back into the network, suddenly, it is part of something that can think, plan, build, and adapt. The colony is the organism. The nest is its body. And just like a human body has a cardiovascular system, a digestive system, and a respiratory system, a mature ant nest has all of those things too, engineered into soil, thatch, leaves, or even the living bodies of the workers themselves. Every tunnel serves a purpose. Every chamber has a function. The architecture is not accidental. It is the physical expression of millions of years of evolutionary pressure, compressed into a patch of ground. To give you a sense of scale, the human city of Manhattan covers about 87 square kilometers and houses roughly 1.6 million people. A single leafcutter ant colony can house up to 6 million individuals in a continuous underground network that a researcher can only fully map by pumping thousands of kilograms of liquid concrete into it and excavating for weeks afterward. And that is just one colony. Now imagine what happens when colonies stop competing with each other and start connecting. We will get there. But first, let us take a tour. Picture yourself shrunk down to the size of a raindrop, standing at the edge of a forest. The first thing you notice is that ants are everywhere, but they are not all living the same way. Some are streaming into holes in the earth. Some are climbing into the canopy. Some are sleeping in acorns. And this is the one that breaks your brain, are not living in a home at all. Let us start with the most common type of colony structure you are going to encounter, the monodome. One queen, one nest. One highly defended, centralized structure with a single royal chamber buried deep in the earth for maximum protection. These colonies are territorial in the way a medieval castle is territorial. There is a clear boundary, and everything outside it is enemy ground. The architecture reflects that. Single entrance tunnels, bottleneck corridors, defensive geometry designed to funnel invaders into kill zones guarded by soldier ants. But then there is polydomy, and this is where things get interesting. Polygamous colonies spread themselves across multiple physically separate nests, all socially connected. Multiple queens, multiple nodes, workers and queens moving freely between locations via underground or surface corridors. Think of it less like a single castle, and more like a Roman Empire, a network of cities sharing resources, labor, and population across a landscape. Polygynous colonies pack nearly twice as many workers into a given area compared to their single queen counterparts. Nearly twice the biomass. Nearly twice the engineering output. And then there are super colonies. And this is your first, wait really, moment. The Argentine ant arrived in Europe hidden in plant shipments. It has no natural predators there. And without predators, something extraordinary happened. Individual colonies stopped treating each other as enemies. Workers from one nest encountering workers from another did not fight. They cooperated, and kept cooperating, and kept connecting. The result is a single interconnected supercolony that stretches over 6,000 kilometers along the Mediterranean coast, from Portugal through Spain and France, all the way into Italy. Billions of workers, thousands of queens, no territorial borders, no intercolony aggression, just one vast continental open-source civilization that crosses 4 countries and operates as a single architectural project with no central command. Out of roughly 14,000 known ant species, fewer than 1% form supercolonies. You are looking at a biological anomaly that operates at a scale most animals cannot even perceive. But not every colony needs a permanent home at all. Here is your second wait, really moment. Army ants, specifically Etiton burchellii in Central and South America, build their home out of themselves, every single night. The bivouac, as it is called, is a living nest made entirely from the interlocked bodies of up to 700,000 workers. They hook their feet together using specialized tarsal claws, layer upon layer, forming a solid organic mass about 1 meter across. The queen and larvae are sealed in the heavily protected geometric center. The walls, the floor, the ceiling, all made of ants. And every morning, the architecture dissolves. The ants unhook, melt into rating columns, and strip more than 1,600 square meters of forest floor of every insect in their path. They can travel at 20 meters per hour. Then, as evening falls, they build the city again, from scratch, from themselves. These same army ants also build living bridges across gaps in the forest floor, algorithmically, adjusting the width of the bridge in real time based on the density of foot traffic crossing it. When traffic drops below a certain threshold, the structure dismantles itself. No foreman, no meeting, just pure distributed biological computation expressed as architecture. Keep watching, because we have not even gotten to the most extraordinary structure yet. In the 1970s, a group of researchers in Brazil did something that sounds almost absurd. They located an abandoned ant nest, drove trucks carrying 10 metric tons of liquid concrete to the site, and pumped every drop of it underground. Then they waited for it to set. Then they excavated, carefully, methodically, for weeks, brushing away soil to reveal what the concrete had filled. What emerged from the ground stopped them cold. It was a structure of breathtaking complexity, and the builders weighed less than a paperclip. The nest of the giant leafcutter ant, Atta laevigata, Atta sextens, and Atta volunviteri, is the undisputed pinnacle of biological architecture on this planet. A mature colony's nest spans more than 50 square meters at the surface and plunges 8 to 9 meters into the subsoil. To hollow out a cavity of that magnitude, the colony's excavator cast must transport over 40 tons of soil to the surface. 40 tons, grain by grain. For comparison, the Great Pyramid of Giza contains roughly 6 million tons of stone, moved by tens of thousands of humans over 20 years. The leafcutter nest contains 40 tons of displaced earth, moved by insects with no eyes directing them, no project manager, and no shared language, completed incrementally over the life of the colony. Inside, the architecture is stratified across functional zones with the precision of a hospital floor plan. Up to 7,000 individual chambers are engineered to perform specific roles. The fungus chambers. Because leafcutters do not eat leaves, they farm a specific fungus on shredded leaf matter as their sole food source, are built as near-perfect spheres, each connected to a vertical transit shaft by a single narrow opening called a peduncle. That geometry is not aesthetic, it is engineering. The spherical shape and narrow neck allow the ants to maintain exactly the right temperature and humidity, 25 to 30 degrees Celsius, for optimal fungal growth. Shift those conditions even slightly, and the entire agricultural system collapses. Deep below the fungus gardens sit the waste chambers. Leafcutter colonies produce enormous quantities of spent, necrotic fungus and dead workers. Rather than leaving this biological hazard near their food supply, dedicated trash handler ants, who are permanently quarantined and never allowed contact with the queen or the gardens, transport all hazardous material to isolated refuse chambers far from the living population. The colony has invented a functioning waste management and quarantine system, independently of any human institution that figured out the same thing. And then, there is the ventilation. On the surface of the nest, workers construct raised soil turrets positioned directly above the nest's central exhaust shafts. When wind passes over those raised structures, it creates a zone of low pressure, the same aerodynamic principle that generates lift under an aircraft wing. That pressure differential pulls stale, CO2-laden air up and out of the deep chambers. Fresh oxygenated air is simultaneously drawn down through peripheral intake tunnels near ground level. The colony has built a passive, wind-powered ventilation system without ever observing wind, without understanding Bernoulli's principle, and without a single worker having seen the full nest they helped construct. But here is what makes this truly extraordinary. When CO2 levels inside the nest rise to dangerous levels, between 5 and 10%, workers detect the chemical shift and immediately begin modifying the surface architecture. They add apertures to the turrets, they widen the exhaust openings, they increase airflow dynamically, in real time. The nest is not just a building. It is a living machine that monitors and edits itself. 6 million individuals, 40 tons of displaced earth, 7,000 purpose-built chambers, a passive ventilation system that exploits fluid dynamics, a functioning agricultural economy, and a quarantined waste management department. You are not looking at an ant nest. You are looking at the most successful civilizational template that has ever existed on this planet. Now let us walk in the opposite direction, all the way to the other end of the spectrum, coming straight from the leafcutter's underground metropolis. Makes what you are about to see feel almost painful by comparison. But here is the thing. The story of the worst home ever built by an ant colony is not a story of failure. It is a story of a creature so ancient, so unchanged, so stubbornly primitive, that the modern world is literally killing it just by existing. Meet the Australian dinosaur ant, Nothomyrmecia macrops. Scientists call it a living fossil, and that is not a casual label. This species possesses anatomical and behavioral traits so unchanged from the earliest ants that evolved in the Cretaceous period that studying it is essentially the same as studying the ancestral template from which all modern ants descended, and its home reflects that, severely. A mature Nothamacea colony contains between 50 and 100 individuals. Not 50,000, not 5 million, 50 to 100. The nest consists of a single hidden entrance, usually tucked under leaf litter or near a tree root to avoid detection, leading to 2 or 3 shallow vertical shafts terminating in a handful of small dead-end side galleries. No specialized chambers, no agricultural zones, no waste management, no ventilation, no thermal control whatsoever. Because the workers are completely monomorphic, every single ant identical in size and shape, with no specialized excavator caste, no soldiers, no dedicated architects. The colony has essentially no construction capacity beyond the most basic scraping. There is no division of labor based on age or role. Every ant is a generalist. Every ant is a hunter. And because every ant acts alone, the colony builds almost nothing collectively. How does a colony of 100 identical ants with no climate control survive the brutal heat of the South Australian outback? It barely does. Workers can only forage at night, when temperatures drop far enough to prevent them cooking alive. Their shallow nests offer almost zero thermal insulation. One sustained heat wave, one predator disturbing the entrance, one human with a shovel, and the entire civilization is gone. And when predators do arrive, the workers do not swarm. They do not fight. They freeze. They curl into a pupal posture and play dead. Ask yourself this. What does it mean to survive for millions of years using the most minimal possible tool set, in the harshest possible environment, with no advantages whatsoever? Because Nothammermetia has been doing exactly that since before the dinosaurs disappeared. It has not evolved. It has not adapted. It has simply endured with 50 ants, 2 tunnels, and a hidden door. The IUCN lists it as critically endangered, not because it is failing as a species, but because the world around it finally changed faster than it could. That is not weakness. That is the oldest form of stubbornness on Earth. Here's the question that sits underneath all of this. Once you know what you know now, how does this happen? How does a creature with a brain smaller than a grain of sand, with no language, no education, no written plans, and no awareness of the building it is constructing, how does it produce ventilation systems, quarantine protocols, agricultural complexes, and continent-spanning civilizations? The answer is that intelligence at its most fundamental level is not about individual brilliance. It is about the emergent behavior of coordinated, interconnected parts following simple rules. Every ant follows chemical signals. Every ant responds to local conditions. No ant sees the whole. And yet the whole, the nest, the colony, the superorganism, is something that no individual ant could comprehend, plan, or even perceive. This is not so different from the way neurons in your brain build a thought. No single neuron thinks, but billions of them, connected and firing in response to local signals, produce consciousness. The ant colony is, in a very real sense, a distributed mind expressed as architecture. And that architecture is permanent, in a way individual lives are not. Wood ant mounds, those massive thatch and resin fortresses built by Formica rufa, have been continuously occupied, expanded, and repaired for over 60 years. The ants alive in those mounds today are not the great-great-grandchildren of the original builders. They are separated by thousands of generations. The queen who started the mound has been dead for decades. Every individual worker who laid the first pine needles has been dead for decades. But the structure persists. It grows. It repairs itself after storms. It has outlived every single architect who built it millions of times over. A building that outlives its builders by millions of generations, maintained by descendants who have never met the founders, housing a civilization that has never stopped expanding. Now here is the fact that lands like a final argument. The oldest confirmed trace fossil of an ant nest, not a nest itself, but the fossilized shape of one carved into rock by an ancient colony, was discovered in Utah and dates back to the late Cretaceous period. Ants were building cities with engineered chambers and transit shafts when the last non-avian dinosaur was still alive. They were here before us. They will almost certainly be here after us. And the whole time, they will be underground, building. We started with a patch of dirt, and what lives underneath it, what has always lived underneath it, is not primitive, not simple, and not something you can unsee now that you know it is there. Next time you step on grass or walk through a forest or stand in a parking lot, somewhere below your feet there is a city running, climate-controlled, ventilated, defended, agricultural. Millions of citizens coordinating without conversation, building without blueprints, enduring without ego. If that does not make you feel genuinely small and genuinely amazed, I do not know what will. If this video changed the way you look at the ground beneath you, hit subscribe. Every week we go this deep into nature, engineering, and the things hiding in plain sight that most people walk right past. Drop a comment telling me which colony type broke your brain the most. I read every single one. And if you know someone who needs to see this, send it to them. The ants have been at this for 100 million years. The least we can do is pay attention.